Testing, testing. 1, 2, 3. Okay. So I tried to put together a small talk, and I ended up having to pare it back because the topic of JavaScript is just huge, and going from ES5 to ES6 introduces even more of the language. So I really couldn't cover everything I wanted to cover. So if I don't cover the particular JavaScript ES6 topic that you're looking for, hit me up after this, and I'll be happy to talk with you about it. There's all sorts of stuff going on. So I'll just give you a quick tour, really, today of some of the features in ES6, which is the current stable version of JavaScript. There's also ES7, ES Next. We'll talk about that in a second. And compare those to some of the idiomatic things that you did in ES5, the previous version of JavaScript, that we've all mostly gotten used to, and what some of the differences are and what some of the new things are that you can do with ES6. So before we get going, a little bit of JavaScript history, right? Some of you may recognize both these pictures, some of you may not. So JavaScript actually was introduced in Netscape Navigator 2. For those of you online, don't worry about this, but if you remember Netscape Navigator 2 and used it, raise your hand. There we go. All right. And it was actually called LiveScript initially when it first came out, and then Netscape later changed the name to JavaScript because of the popularity of Java that was occurring also at the same time. So we piggybacked off of the popularity of Java, and that may have been good or bad. That's up to you. We'll discuss later. The guy on the right-hand side is the guy at Netscape that invented that. That's Brendan Eich. He's the one that created JavaScript. And the first version took a total of 25 days because that's how long he was given to add it into the browser because it needed a scripting language. So there's your history for you. But even more than that, I've sort of broken the timeline of JavaScript down into 3 major sections. There's the olden times that some of us remember that led up to the ECMAScript 3 standardization. And then between 99 and 2012, I call that the Dark Ages. So if any of you have used IE6, that's why we call it that. There were hardly any standards across browsers. Every browser vendor decided they were going to do things differently, have a slightly different API. Remember the fight between layers and divs? That was a long time ago. So all sorts of stuff happened during this period. But then in 2012, people came to their senses and said, you know what, we should probably standardize this because web developers are miserable all over the world. In 2009, there was the ES5 standard. And then in 2012, they decided that, you know what, we're going to make a new one and add some more features. We're going to make this work. And that was called ES Harmony, which is now what is ES6 or ES 2015, which is the technical specification name. And ES6 actually was standardized by ECMA in 2015. And they decided that instead of calling it ES6, we're just going to create a new JavaScript standard every year. So we'll just slap the year on there. So ES6 is the same as ES 2015. There really is no ES7. It's going to be ES 2016. And there's ES Next. There's various stages of the proposals. So ECMA is the actual standardization body, which is the actual name for the language. It's actually ECMAScript. Everybody just calls it JavaScript. It's actually standardized under ECMAScript name. TC39 is the actual working committee that puts the standards together. So if any of you need to get good sleep at night, feel free to head over to the committee's working body and read some of the proposals and different stages that are out there. And again, we talked about the yearly standards and the renaming. So how well is ES6 supported? On the desktop, pretty good. We're almost at 100% on all the major greenfield browsers. Some of the other lesser known browser engines that are used in Conqueror and some of the others aren't quite there, obviously. But for Edge, Firefox, and Chrome, we're looking good. For Node, Node 6 supports most of ES 2015. And then on mobile, forget about it. So because of some of the gaps here, especially on the server runtimes and on mobile, and for some of the things that we would like to have on the desktop, we are using transpilers like Babel. Babel seems to be the choice du jour, given there also was Tracer and at least 1 or 2 others back in the beginning, a couple of years back. But Babel's a transpiler, so now we can actually write current JavaScript based on the standard, and that includes 2016, ES Next if you want to include some of those. Babel supports all those various versions of the language. Of course, the further out you get, the chances of you writing code that a year down the road will no longer transpile is fairly high, because that may have been dropped, kind of like the whole object.observe functionality. That was in the standards and proposed, and then all of a sudden it got dropped, and now the transpiler doesn't support it. So I'm pretty good, but regardless of all that, if you're using a transpiler like Babel, you're probably pretty good to write ES 2015 for pretty much any platform. So let's get into some of the different things that are introduced by ES6. I'm confusing myself calling it ES6 and ES 2015. So they're equivalent. If I say one, I mean the other. So the first thing we're going to talk about is arrow functions. Now again, for those of you that are using other languages that already have some of these features, kudos to you. It's good that JavaScript got some of these, right? So JavaScript was lacking in a number of areas. This standard hopefully makes up for some of those. So short arrow syntax is really just a way to have shorter functional expressions and statement bodies. And unlike functions, arrows share the same lexical context as their surrounding code. And we'll talk about that in a second. So for each one of these, I have a set of examples that we'll talk about. So if you take a look at it, when I talk about the context of a function, every function in JavaScript has a context, including the global context, because there's one single function, like a main function, that runs your entire thread. Okay, so there is a global function that your code is running in. And when you're running in that global function, the context of the keyword this is actually global or window. That's what this refers to. If you're inside another function, that this value is tied to the scope in that function, as JavaScript is functionally scoped. So if you look at ES5, if we wanted to write a function and still access or retain access to the scope from the parent scope that the function was called in, we would have to do some things like bind, or hopefully use a function that allowed us to pass a context, which map also lets us do as well. In ES6, we don't have to do that. We can actually just create the arrow function, and the arrow function will actually retain the context just fine. So this inside of an arrow function is the same this context as the surrounding parent scope. You don't have to pass new context in or do anything weird like binding to get it. So if we look at the first ES5 example up here with the lexical list, we have an object literal. It's got a function called log languages. And inside that function, we actually do a for each. And inside that for each, which takes a function, we want to actually access some of the properties on the object that we're a part of. In order to do that, I have to actually pass this, the surrounding scope context, to the for each function in order to access it. This makes your code kind of awkward, kind of weird. It gets kind of long. In ES6, it's a lot simpler because I can simply just pass an arrow function as the callback to for each, and I don't have to worry about binding or passing a context. I have access to it by just using this. It's the same as the surrounding scope that the function was called in. So much easier to read. Less verbose is always good.
Do you intend to mention that you're using a different way to do string interpolation?
I'll get to that in a second. But yes, good catch. So outside of arrow functions, the next really cool thing we got is block scoping. Yes, JavaScript didn't have block scoping before. Like I said, JavaScript is functional scope. So the scope of any variable declared is in the scope of the function that it was declared in. And like I said, there's a global function that executes the main thread of your code. So everything is a function. In block scoping, we get let and const. Let is to allow us to declare block scoped variables, blocks being inside of control structures or looping structures. And then const, which is also block scoped, allows us to declare a constant that can't be reassigned. There's some caveats with that. So just quickly, in order to get block scoping in ES5, we had to resort to immediately invoked function expressions, IIFEs, which on the left you can see there inside of that if block. We actually create a function expression where we do most of our code and immediately execute it. That allows us to actually have A be a local variable inside that function scope. So in order to create a new scope, we had to create a new function, hence IIFEs. We could still access parent scope around that if we didn't declare something. So again, you can see the assignment to B here actually overwrites the scope outside. In ES6, we don't have to resort to weird immediately executing function expressions. We can actually just say let, and now that variable A is block scoped to the if block. Like I said, most other languages have block scoping. This is new for JavaScript. So much less code, much easier to read. And we'll hang up on the screen there. So let's talk about constants, which are other block scoped variable type. In ES5, if we wanted to declare a constant, something that we couldn't actually overwrite later, we would actually use the define properties function on the global object to create the variable. And each variable you declare actually has a number of properties: enumerable, writable, readable. Right? And so what we would do is we would create a variable called pi, and we would ensure that it's enumerable because constants should be enumerable if you want to loop through them or grab them off something. And we're going to set writable to false. That way we can overwrite it. And then we'll also assign a value by default since we're declaring it writable false. And if we try to reassign it there, we still get the original value. ES5 wouldn't let us do that. But that entire block of 7, 8 lines just to declare a constant variable is kind of a pain. It doesn't make it very useful. You tend not to do that, and so there's a lot of stomping on other people's variables in ES5, right? In ES6, however, we could just say const to declare it, and then if we try to assign to it, we actually get a type error thrown, which is much better, much less code, and we never end up getting to that console log here. String templating, as was alluded to before. So string templating allows me to do string interpolation. So if you're familiar with languages like Perl, where you can actually interpolate a variable inside a string expression itself or any other kind of language expression inside, we now have that ability in JavaScript. It also comes with multi-line strings without weird escaping and concatenation across lines. So basic string templating, you really couldn't do in ES5. You would have to actually resort to concatenation with the plus operator with the strings, or you would have to actually do something weird like create a list of strings inside of an array and then join them with a new line, with a comma, with whatever, right? So really weird tricks to get interpolation inside of strings. You just have to do it one of those two ways. In ES6, it's actually much easier. If you look at the first console log statement, I can actually just surround the variable with a $sign and curly braces, and it gets interpolated inside the string. Now, the string templates are in backticks. That's what denotes a string template versus a single quote or a double quote. We can also do the same thing for accessing properties on objects, as well as arrays, which you can see in the second console log. We can also interpolate expressions. Any real expression that you can do in JavaScript can be interpolated inside of those curly braces inside of a string template. Likewise, we can call functions, which is what that last one does. So any really real valid JavaScript expression will work in an interpolation block in a string. For multi-line strings, in ES5, again, you had to resort to weird things like concatenation, or you would have to actually do a new line and then escape it to continue on to the next one. And then you get really weird white spacing. Unless you make sure that all of your stuff goes right back to the left-hand side, you're going to get the leading white space on some of those. It becomes kind of a pain. You still have the white space problem in ES6, but with the backticks, you can simply just hit return and keep typing. And then when you get done with the string, end the backticks. So there's no concatenation, there's no escaping of lines afterward. And that bottom one, because I hit a new line and actual return after the spans and then type the second line, that new line actually shows up as part of the string. Some other interesting things that were introduced are specifically dealing with objects, specifically shorthands for initializing object properties or methods on objects, as well as doing computed properties. So the property shorthand notation is really just a readability convenience for programmers. But if you look at the left-hand side for the ES5, when we return the object from that getPoint function, our property names in the returned object literal are the same as the variable names that we're using. So we just say x:x, y:y. It's kind of redundant. So you actually can get rid of that in ES6, and you can just say x, y, and the assumption by JavaScript is that, oh, that your property names in this object should be the same as the name of your variable. And so we get the same output. An object with an x and a y property. Pretty simple. Method shorthand on objects is, I think, much better than the property shorthand. So declaring functions as methods on object literals in ES5, we actually declare a property to string just like any other property, except this time we assign a function expression. And that gets a bit verbose. We can call it. In ES6, we don't have to use the function keyword at all. We just simply declare the function without the function keyword. No colon, it's not like a property. It's recognized as an actual method when parsed by the language. And we set it up that way. A little bit shorter, more readable. This is the more interesting piece of the object properties changes. Computed properties. So if we want to access a property on an object, and we want to do it dynamically at runtime by computing that property name, we can now do that. And we can do that inside of the square brackets to access the object. So inside the square brackets, JavaScript will now allow you to pass in the expression. We can evaluate variables, functions, whatever you would like, to end up with a string that should be the name of the property you want to access. So here, for instance, in ES5 land, if we wanted to do that, we would actually have to concatenate to build the string. And again, for objects and arrays, you can use the square bracket notation to do that. And access each of those, or assign each of those members of the object. In ES6 land, we can actually just create the object with different computed properties. The first one takes the value of a variable, the second one takes the return from a function call. Destructuring. So again, some languages like Perl and PHP already have this, the ability to actually pull values from one type of collection, an array or an object, into another collection, and then assign those particular values to something in the local scope versus assigning them to a whole new object we're trying to extract or shove things into, right? So with destructuring, if I wanted to create some globally scoped variables to access some members of that foo object, I would actually have to pull them out individually and declare them. And then I could access them below. Same thing with an array. I have to pull them out individually by index. In ES6, I can simply do destructuring. So if you look at the second line in the ES6 block, I can say const bar comma baz inside of the curly braces, and that actually will pull the bar and baz properties from the object on the right-hand side of that assignment and assign them to variables called bar and baz in the current context. Those aren't part of some other object. I can do the same thing with an array. I can extrapolate and pull things out of an array into the local or global context as well. This is a handy feature. It's much less verbose to do it with destructuring. right? But we can also alias those as well. So say I wanted to pull out bar and baz from that object, but I wanted to name them something else in the local scope. Well, I can do that by actually using a colon and giving it an alias name for that variable. So now I have variables A and B in the scope that came from the variables bar and baz inside that object as it was destructured. I can do the same thing with an array. And notice that when you're destructuring objects and arrays, you use the appropriate notation, either curly braces or square braces, depending on which one you're trying to destructure. Square braces for arrays, curly braces for objects.
If we go back on that one,
Yeah.
clarify what we're looking at in the top half of the comment, with a comment line 3, tells me that the result of doing this is that bar evaluates to 5, right?
Yeah, that should be A and B. That's a mistype on my part.
Okay, so the result of line 2 is that A is now a new local constant that refers to evaluate to 5.
Correct. A and B are now new local consts in that scope that refer to the values of bar and baz in the object.
I think we've not really dealt with it in JavaScript. The line 2 syntax seems backwards. But that's just what they decided.
Yeah, there's,
When you want A colon bar, like const A, and it gets the value from bar.
potentially, yeah, that does make sense. And you should read some of the ES Discuss forums on this stuff. It's like YouTube comments, right? It's awful. So yeah, there's different ways to do that, and one may be more preferable over the other, but this is the syntax we ended up with. And it gets expanded on, and it could be because of some of the other expanded features like defaulting and destructuring and nested destructuring, which I'm going to talk about next. That might have affected why they went with this particular syntax.
Sequence doesn't matter.
Huh?
The sequence of the bond matter, so you save and you change the sequence.
In an object, it doesn't matter. I could have swapped those, right? I could have done baz colon B comma bar colon A. Doesn't matter.
So on that
Right.
array one, the word before the colon is irrelevant. Does it have to be the word for one?
No, it doesn't have to be the word for one. That's just,
Irrelevant.
that's irrelevant. It's just that I was going to pull it into something called one and then decided to give it an alias. Right. Yeah, it's kind of overly verbose, but I was just trying to show the point with the arrays. Yeah, arrays, if you're destructuring, they do have to be in order.
Doing something assignment-like, it's really hard to start thinking left to right versus right to left, but you've been doing it the same way that C has done it for many, many years.
Oh, sure, sure. And well, I mean, so Perl and PHP have destructuring as well that works that way.
Bar colon A, it's just like the destructuring in Perl is still, you are declaring a variable that's on the left and you're assigning it something that's on the right, just like it always is.
True. Well, I'm declaring on the left here and assigning from the thing on the right here.
No, you're talking about
You're talking about within the brackets. Right.
You're going to be thinking kind of right to left, right?
Right. Yeah, yeah, I agree. I agree.
But the whole syntax is backwards.
Yeah.
Probably go all the way back.
Well, I think the next thing that we're going to talk about might actually be the reason that affected that, right? So pulling out deeply nested properties from objects, right? So we can actually not just destructure a single level object with the top level properties, we can go and hit nested properties as well. So if we look at the object that we've got here, it's got a string, it's got a nested object called things, and it's got a nested array called years. I can actually, with that first statement, right after that object declaration, get name and one from that object, right? So name, obviously coming from name like we did before with the destructuring. Things, I'm saying from things, grab the following. So it's things colon, and now we're destructuring things in a nested fashion. And I'm going to get the property called one out of that, right? So nested destructuring can go a lot of levels deep, and I think that maybe, even though the previous syntax is weird, this might be one of the things that affected why they went that way, because they needed a way to do destructuring on nested objects and properties. And that would be, how would you integrate that with something that you're really thinking should be, you know, right to left from an assignment standpoint? So, but again, I still agree with the previous statement. Now, if you're trying to destructure something and pull it out and it doesn't exist, you're just going to get undefined. So in the bottom one, we have an object with a 1 and a 2 property, but no 3, and then we're trying to destructure the 3 property out of it. We get 3 declared in our local scope, but the value is just undefined because it didn't exist in the right-hand side of that assignment statement for the destructuring. Now, destructuring makes it easy to do a lot of pretty nifty things. Number one, swapping variables without an auxiliary variable, right? So we can do that in the first block up here. We actually swap A and B with no temporary variable to hold values during the swap. So we can simply just use the destructuring on both sides to swap the values, right? We can also access by dynamic keys, much like computed properties in object. So we can actually set up a key as a string and then use that and access a computed property via destructuring that matches the property on the object, and then assign it to an alias. And we can also assign defaults when destructuring. So like before, when something didn't exist, we ended up getting undefined. In this case, we can actually assign a default. So go ahead and try to grab the much property out of that object, and if it doesn't exist, or if it comes back as undefined, assign it this value. And in arrays, we can actually skip over elements when we're destructuring. So we'll skip over the first 2 and just grab the second 2. Any other questions on the destructuring real quick before I move on?
I mean, you grab the last element in the array
Can you just grab the last one in an array?
without knowing the number.
With destructuring, no, would be kind of hard.
They can't do tail relative position.
Yeah, so when we talk about the spread and rest operators, we'll get into a little more of that. But yeah, for getting the last, it's going to be kind of hard because typically in ES6 standard, you can't do a rest operator. It has to be used on the last argument of a function or the thing that you're destructuring, but we'll hit that in just a minute here, but right now. So function arguments, kind of a vague title, but under function arguments, I want to talk about default arguments, which are going to be very similar to what we saw with the default values used in destructuring on the left-hand side. And then we're going to talk about the spread and the rest operator. All fun stuff. So in ES5, if you're used to creating functions and you want to default a value so that you have basically an optional argument to the function, you're probably used to doing something like the above, where if the variable argument passed in is undefined, then you just go ahead and assign it some default. That's kind of verbose, kind of ugly to look at. With ES6, it's much better because much like the destructuring, I can just assign a value right there as the default inside of the actual function signature. Either way, we're always Batman. So destructuring and defaults on function arguments. So not only can I use destructuring for variable assignment, I can use destructuring on the arguments coming into my function. So say my function needs to take an object. In this case, random is going to take an object which should have 2 properties, min and max. I can go ahead and destructure that instead of just saying random, props, and then try to access props.min, props.max. Here I'm going to destructure whatever object they pass in, and now I've automatically got a min and a max variable available in the scope of my function. Okay? So we can just access them directly. I can even default them so that when I call it with just one of them, the other one I get the default for. So in the second call to random, the min wasn't passed, so it defaults to 1. Now we can even default the entire object. So not only are we destructuring the object passed in, we're saying that if the object passed in is empty, so undefined, then assign an empty object as the thing to destructure from here, right? So in that last call to random with nothing, since undefined is there, the actual argument defaults to the empty object literal, which is then destructured into min and max, which then get just their defaults since nothing was passed in. Yeah, so, okay, kind of weird. So first, let's look at the last call to random. We don't pass anything in, right? So the actual argument being passed in is undefined, right? So because it's undefined, the argument here that we're looking at, that first block where it defaults to min and max, is going to be undefined. But because we said equals empty object, literal, that default is only assigned if the actual argument is undefined, which it is. So now the argument is, before we get to the destructuring, it's now an object literal, empty. And then it proceeds to do the destructuring, trying to pull out min and max from an empty object literal, which those themselves, those properties aren't defined in there. So therefore, min and max get assigned the defaults.
Okay, so that's the order. First you do default values, and then you do destruction.
Outer defaults first,
Right.
equals empty literal. Inner defaults if you're destructuring, right? So
How would it fail if you didn't have the empty object?
if I didn't have the empty object, you would still end up with undefined. It would really kind of fail because there's nothing for it. It can't pull anything out of there. So you'd have undefined for min and max because those defaults never happen.
That wouldn't fail.
That's a good question. It's really going to depend on the transpiler because
Well, what's the real language spec say?
I would have to look at the real language spec to see what's supposed to happen there. There's so much going on with destructuring because we could do nested destructuring and defaulting of objects and stuff. These argument things can get really weird if you start extrapolating, right? But that's an interesting question. I'll have to look that up once this is over. So going from destructuring arguments and defaults, let's take a look at the spread operator. So the spread operator is just the 3 dots. And what those do is it takes some collection, an array or an object, and at the shallowest level spreads them out into the current context. So it pulls them out of the collection and places them in whatever context you're using the spread operator, right? So any of you that have done React and Redux specifically, this example might look familiar to you. Here's an example of a reducer function that takes the current state in an action and then should return some new state, right? And in the one particular case for set age, we return the new state in which we use the spread operator to pull in the current state and then overwrite the age on there with the age passed in on the action. So in this particular case, when I'm using the ... the spread operator there, it takes all of the properties from the current state object and puts them into the scope of the object I'm declaring them in. So if the current state object had, in this case, name and age, here we're getting name and then age as well. But then I do age again after the spread. And because that one occurred later on, it will actually shadow the one above it. And so we get the new age based on the action versus the one that was actually extrapolated via the spread operator. So the example of that down here, if we start off with a state that has my name and my previous age, and then we create an action with my current age, and then we pass it to the reducer, we still get what we expect, but that age 41 actually overwrote age 40, which was pulled out via the spread operator. Does that make sense? So the spread will work with objects and arrays, and I have an example with arrays as well.
It doesn't matter how many properties state have.
As long as they're enumerable, it'll pull them out of the top level. It's not going to descend into nested objects and their properties, just at the top level. All right, so you can kind of think of it as a shallow copy, what we were doing before. So using spread with arrays is fairly handy and lets us do lots of all sorts of really cool stuff. So the first one is passing arguments to functions at runtime that might be computed, right? We can't just hard code the function call with the parameters. Say we're getting some input from the user, it's calculated, whatever. In ES5 land, we would typically use call or apply to call that function. And then we would pass the actual arguments based on the one we're using. So apply actually takes the arguments as an array, call takes them individually, right? So we would do apply here, and then we would pass our array of nums into the max function, right? In ES6 land, we can simply, instead of calling apply, we can just spread those out. We can just say spread operator nums, and that actually will call the max function with 4 arguments individually. So no need for call or apply, right? The second case is joining strings, or joining arrays rather, right? So if we wanted to join arrays in JavaScript land in ES5, we would actually take the first array and use array.concat to concatenate a second array. We could do the same thing in ES6 by simply just using the spread operator. And again, as long as these are arrays of actual native values and not references like objects and arrays, then you're actually doing a copy. So we end up with a completely new array, and we don't modify A or B in any of the situations. And actually, all of these should be non-mutating for both ES5 and ES6. We can also copy an array. Like I said, the spread operator is really easy to use for copying. To do the same thing in ES5, we're going to have to call slice to try to get a copy of that array. We can't really use splice. Splice is a mutating method. Right? And if we wanted to actually splice some arrays together, we can actually do that much easier with the spread operator, because I can use the spread operator multiple times, and I can use them on literals too. So array literals, object literals, it doesn't matter. To do that same thing where we're going to splice in the array D with some other numbers in an immediate array, to do that in ES5, we have to contort ourselves and call slice to get the first element, and then concat 3 different arrays, one of which is a slice of the first array as well. So it becomes kind of weird. No one wants to look at the bottom code on the left-hand side there very long. Then you start worrying about what's getting sliced and concated and moved. So again, a lot of the stuff that I'm talking about with ES6 really are, some of them provide some features that are useful, like swapping variables, copying, joining, splicing, things like that. But a lot of the stuff you're going to see is only marginally functionally useful, and most of it is really about readability and access to the code and making code more succinct and typing less of it. All right. Some things are functional, obviously, but it's really an overall improvement to the language. All right, the rest operator is the same as the spread operator, it's just the 3 dots. The difference is in how you use it in the context. So let's say in ES5, I wanted to create a function that took a single first arg and then any number of variable arguments after that, right? In ES5, we would actually not declare those other variables because we want any number of them, any of them could come in. And we actually create our arguments that were passed to us based on the internal arguments variable that's available inside of all functions, right? So we can use that arguments value and use slice on that to actually get those arguments as a real array, right? Arguments is not a real array. It has no array methods on it. You can index it. It has a length. That's it. There's no map, no filter, no reduce. We want to actually turn that into a real array, which is the reason for that first line in that function. Then we can take all the args that were there and join them with the separator. In ES6, it's much easier because now I can actually use the spread operator to say, for all the rest of the arguments passed to this function, past the first one, shove them all into this array called args. That automatically gathers up every other argument passed to my function and puts it in an array called args that I can then access. So I no longer have to call slice on arguments to get variable arguments. That is a nice functional feature and, frankly, also easier to read.
If you don't pass the last 3 parameters in the last 4, what happens to args?
Args is an empty array, which is a good default, I think, because if you're going to use it and call array methods on it, those typically have a sensible result if the array is empty, right? Or they just won't do it. Array.map, empty array, not going to map it. Just return. And we could even do it inside of assignments to gather stuff as well. So in the first example up here, we can actually destructure that list array, get the head, and then get the tail, right? Could do the same thing with assignment down here. This is very similar to the reducer example that we had, where we're actually just going to grab the first two properties we want out of that object and then shove all the other properties into a variable called props. So just grab the ones that we care about, leave the rest. Any questions on spread and rest? Okay. Iterators and arrays. Like I said, there's so many topics. I could have been here for like 3 hours talking about stuff. So I'm trying to blow through it kind of quickly. If you have questions, feel free to just raise your hand. So JavaScript kind of had iterators on ES5. So if you're using for loops or you're using collections like arrays, obviously they would work much like iterators work on collections and allow you to iterate through the values until there were no more. Now we have actual iterators that you can create in your application yourself as well. And we have conveniences for using those like for of instead of for in for looping through values. And I'll give you some examples here. So in ES5, if we had an array, we could for each that array to get the value and not just the index, you know, versus a for loop, where if we use a for loop, we actually have to use the index and index the original thing we're trying to loop through to get the value each time. Sometimes you don't care about the index. You have a collection, you just want the values. Why deal with the index, right? So in ES6 land, I can actually use for of and loop through those array elements by value directly. So for each element in the array, log the element, that element is the value, right? If we had done for in, for element in array, we would have gotten the index and had to have actually accessed it like we did in the for loop up here in ES5. For of allows us to actually use an under the hood iterator to get the values progressively of a collection. So what exactly is an iterator? So it just lets us access collections until there's no more values left, right? And iterators are lazy, meaning that I don't have to get the next value until I actually call some method on the iterator to get it. So if we were going to write an iterator in ES5 land, that's what you would get on the left-hand side. So we created a function called iterator for, which takes a list, some kind of array collection. And what it does is it returns an object with the next method. And every time you call the next method on that returned object, you'll get the next item in the array. We use it for an array down here. We create a variable called iter, which is the iterator for that array containing 1, 2, and 3. We can actually get the first value by calling iter.next. And then while the done value is false, we simply just keep looping. So an iterator, and it's the same, this would actually qualify as an iterator in ES6 as well. If you used it in any instance where a real iterator was needed, for of, etc., it would accept the return result from iterator for. Because an iterator just has to have a next method, and that next method should return an object on each call that has a value property and a done property. So once we loop through 1, 2, and 3, the last output we get is actually value undefined, done, true. That's how looping constructs that use iterators know when to stop. So I'm just going to run right through this guy until it says done, and then I'll stop. That's what our iterator does. And we can actually, in ES6 land, access the iterator of collections directly by using symbol.iterator. And I'm not going to talk about symbols, which is a new variable type in ES6. I believe Firefox and Chrome support those pretty widely. So I tested most of this code on Chrome, latest version, so it all works. So you can actually take an array, either a literal or an array variable, and access the symbol.iterator property, which is going to be a function, much like our iterator for. So if you call it, it's going to return you an iterator for that array. And then we can take that and use it just like we did on the left-hand side and call next, next, next until we get done. Now we could continue calling next after that last one, and we'd still end up getting undefined true, undefined true, undefined true. But now we have manual control over iterating a collection. Lazy declarative programming for the win. Which gets us into generators. So iterators are a lot easier to write when you use a generator. More can be said on generators, but generators are a specific type of function in JavaScript. And you'll notice that it's declared with the function asterisk or the function star in front of the function name. That means that that is a generator function, which means that it's going to return an iterator, and that iterator that it returns will basically give you all the values that that function yields. So yield is a new keyword here. So that iterator that gets returned is going to basically, every time I call next on it, it's going to yield one item from the list. So that's a lazy for loop. I create an iterator for this array of 1, 2, 3, and then I can just basically loop through it with for of and get the value. It's essentially how our by hand iterator for worked in ES5. But generators make it a bit easier, less verbose, and the yield keyword. The yield is kind of like return, but not really. Think of yield as an async return, right? Now, if I tried to use iter again after that for of, I wouldn't be able to. Like I said, it was already undefined and done as true. So I could just get another iterator for the array and loop through it again, right? So iterators are one-time use. You can't use an iterator and then rewind it and use it again. You just get a new iterator. Okay? I mean, yeah, you could assign that iterator to some other value. But yeah, remember it's copied by reference because it's an actual object. So you'd still be at the same spot as you were in the other iterator. So again, yeah, yield and generators and iterators, there's lots more to talk about on that, but I'm just going to, that's the overview I gave you today. I think the other interesting thing that we're going to talk about, second to last here, is classes. And if you're a functional programming fanatic like me, you're not really too big on whether JavaScript had classes or not. But people like OO, you choose whichever works best for the situation, right? Functional, OO, we could have that debate some other time. But JavaScript now has classes. Now keep in mind that the classes in JavaScript are not real classes like you would think of with C++ or Java or other things. So in those languages, classes are really like a blueprint. And you use that blueprint to create instances of the thing the blueprint is for. JavaScript is prototypal in its nature, both with objects and inheritance, right? So it works based off a prototype chain. Every object has a prototype that's based on some other object. So classes in ES6 are really just syntactic sugar on top of the existing prototypal OO that JavaScript implements. And I'll give you some examples of sort of how that works here. So in ES5, we want to create some classes. I use air quotes there for those listening in. Classes in ES5 really are just functions that are called with the new keyword, right? So if we take a function person and we start assigning to this, remember this has the context of the inner scope of that function. JavaScript is functional scoped. And we can actually add properties to that function's prototype, person.prototype.greet, and then type of. And we can assign objects or properties, we can assign the properties directly on the actual function itself, where you see I'm doing person.type up there, right? So basically what we're emulating here is the person function, given that I capitalize it, it should be used like a constructor for an object in another language, right? It takes parameters, it then assigns those to this, which is the internal representation of the instance that's being created. When I assign to the actual function name, that's much like a static or class variable, right? So it's available on the class itself. It's not part of the instance. When I assign to the prototype of that function, the greet and the type of, that means every instance of an object created when I use person as a constructor with new is going to have access to the greet and the type of function. Now let's say I want to create another object that inherits from person in ES5. We would do that like the employee class down here. I would declare, just like above, employee as a function, except that I would actually invoke the person constructor directly, no new, and pass it my own this, so that everything that it did got assigned to me. So now I have a name. And then I would assign my own instance variables. I can have my own class properties with employee.type or static properties, pseudo, right? And then I can also, at the very bottom, set up my own instance methods on the prototype. Now, the way to set up the inheritance is that piece right up in the middle there where it says set up inheritance via prototype chain. I'm going to take the prototype object property of the employee function, and I'm going to assign it a new object that is based on the prototype of the person function. So now person's prototype object is in my prototype chain. So with JavaScript, if I call a function on my object, JavaScript is first going to look directly at my object and see, do I have that function declared? Oh, I don't? Okay, well then now follow the prototype. Go to that. Does that prototype have it declared? Nope. Does it have a prototype? Follow that one. It's a giant prototype chain. It'll keep following it all the way down until it finds the function, or it comes back with couldn't find it, and you get can't call method X undefined, right? So that's how we create the prototype chain to ensure that employee is inheriting from person, and we can call person's functions. The second piece is the constructor. Now, when I reassign the prototype, before I did that, employee.prototype.constructor is actually the employee function up here. Which function created me? That's what the constructor property is on the prototype, right? When I reassign the prototype, I just smashed that guy. Now my prototype.constructor is equal to person. Well, that's not the function that created me. So if you want to use things like instance of, you're gonna be hosed if you're doing checks for that, looking to try to find out what kind of pseudotype your variable is, right? To correct that, we have to reassign the constructor on our prototype, and we just reassign it to the function that created us, right? This is all super complicated. I could show you a diagram, and it would look like spaghetti, how this all works under the hood. But that's how we had to do classes in ES5. Right? So, well, this is ES5 still. This is how you call those. It gets better. So here we create a new employee. We call greet. And if you notice, it actually does call my greet. It actually calls person's greet first. It concats that with mine. If you look back here at the greet function, person's greet actually says, hello, my name is. And then for employees, it says I work at, and then gives the company name. So calling super methods works great, right? And then we can just access the static property using that method that we declared to get to it. Again, this is all sorts of complicated. You don't want to manage that, especially if you have multiple classes, a whole hierarchy. Not good. ES6 land, we now have this. Here's my person and employee classes. We actually have the class keyword. Class person has a static property. Sweet, static property name equals what? It's got a constructor. It's a named constructor. Easy enough. Well, we got shorthand method properties, so now we have methods defined on our class. We're done. That's way easier than what we just did before. Now, if we want to actually have employee inherit from person, we have the extends keyword. Class person extends, class employee extends person. Same thing, we set up a static property, we have a constructor. In order to call the parent constructor, we use the new super function property that's available inside of classes. We can also use it inside the greet function. We can say super.greet to call the parent greet, right? So now with this syntactic sugar, it looks like regular classes everybody's used to. Much easier to read, much nicer. But keep in mind, under the hood, it's still that. Nothing changed functionally. And again, we can call it just like before. No real differences there. Any questions on classes?
Single or multiple inheritance?
Single. Everybody knows multiple inheritance is an any pattern, right? All right, so the last thing I wanted to cover very briefly is just modules, and there's way too much on modules to cover, but I just want to cover a couple important things. Number one, as far as the module spec goes for ES6, the loaders for the different browsers or environments like Node, etc., have not been standardized in the spec yet. So they're not quite sure how they really want to do loading of modules in the browser, right? Because they're now having to do, well, we have script tags and we have XHR calls that can return JavaScript. We have JSONP. All this, how do we get the script into the browser environment? How do we load that asynchronously? When should they execute, et cetera? So this hasn't been standardized yet, but there are existing module loaders out there, AMD, System.js, that work great in browsers. And then, of course, for Node environments, you have CommonJS module format. Now, these are all module formats that have been defined well before the ES6 spec. They exist. There's libraries for them. If you use require.js or any of those, you're probably familiar with some of those formats. But ES6 is defining a real module format that hopefully will be implemented in the future. It's supported through transpilation with things like Babel right now. So module style. So when I'm talking about ES5, I'm going to talk about CommonJS, and then I'm going to compare it to the ES6 standard and what's going on. So in ES5 land, if we had an application, we could actually pull in a function from another JavaScript module, hence the require, and assign it to a local variable and then use that. In this case, we're taking the object returned from the libmath module, assigning it to a variable called math, and then we can access the pieces returned by that module. We have to be exporting a sum and a constant pi, right? So in CommonJS land, the keywords that they have are exports. So exports is a keyword in CommonJS. When CommonJS sees an exports, that's the object that you're assigning to for that module. Anything assigned to exports ends up getting exported when that module is required. So in this case, just two items. So we can access, in the top one, we could access math.sum and math.pi, right? In ES6, same thing, except that there's no exports object. There's actually an export keyword, and I can export directly. So I can say export this function. It's got a name. It'll be called sum. Export this constant, or this variable. It's called pi. Still accesses the same way, except instead of using require, we say import namespace object variable name from whatever the actual module is, relative path. Now, we can also do named and default exports, right? So if we look at CommonJS land, our named exports are much like before. We actually just assigned the exports object, exports.sum, exports.div. But we can also assign a default export. All right, and I'll talk about how that actually gets assigned. The default export is actually the full thing that gets assigned when you do the require in CommonJS. All right, so if I had a default export, in this case, we have a default export of a function, which we're just squaring some number. Then if I did import square from libmath, square is now a function. But that function also has properties of sum and div that I can access. So not only is the default export that you make, if you have one, a function, a class, something else, but it then also has properties that are the named exports from the file. All right. ES6 makes it a little simpler. We just have the keywords export default. All right. So instead of trying to merge in the exports default in CommonJS with what we already assigned to the existing exports object, and then assign that to module.exports, which is what the whole exports object on the module that's being exported, what that should be. We can just say export sum div and then export default.
So you use the same export for different functions, they will override.
For ES6 or ES5?
ES5.
ES5, there's two keywords that CommonJS environments set up, right? Number one is module, and that module is an object that defines the actual module being defined by that file. And then on that module is a property called exports, which itself is an object, which should contain the properties that you want to export as part of that module. Now, when I say exports.div, and I'm assigning there, exports is the same as module.exports. The only difference is with the default exports is that I have to have a property on there that is a default.
We're testing.
Oh, okay. Sure.
Make sure we can thank Dave for his great presentation. Definitely discuss after.
Yeah, tons of stuff. It went on and on.
Before you all leave, can I just get a picture of you looking really engaged over there?
You're going to have to act.
Awesome. Okay, now look at me and look very happy and satisfied. Wonderful. Thank you.